Hello and welcome to video number 2 in this series. In this video I'm going to be reviewing the number line and thinking about numbers as points along a number line. And that's going to help us with thinking about arithmetic properties that involve zero and negative numbers, inequalities and distances. So here we have a real number line with 0 and then negative numbers over here and positive numbers on the other side, and I can mark off integers, for example -3 and +3. I can mark off rational numbers, say like -1/2 and 1/3. So let's mark off some other integers here too, so 1 and 2, and then on the negative side we've got -1 here and -2 here. And then I can also put irrational numbers on here. So for example, if I go to about here, that's where √2 would be, because it's 1.14 and a whole bunch of other decimals. Pi is 3.14 and then a bunch more decimals, so that's going to be about here. In general, if I have a point, say it's labeled A, then there is a real number associated with that point, lowercase a, and that represents the distance between the point A and 0, which is referred to as the origin. So if I have another point here, B, then lowercase b would be the distance between the point B and the origin. So now that we can think about numbers along a number line, and we have positive numbers to the right of the origin and negative numbers to the left of the origin, it becomes easier to think about sign rules. So if I multiply two numbers together, A times B, then A could be negative or positive, and B could be negative or positive. If I multiply two negative numbers together, then I get a positive number, or if I multiply two positive numbers together, I get a positive number. Whereas if A is positive and B is negative, I'll get a negative result, and if A is negative and B is positive, again I'll get a negative result. And we have a similar situation with quotients. So A divided by B, again, A can be negative or positive, B can be negative or positive. If I divide A by B and they're both negative or they're both positive, I get a positive result. If A is positive and B is negative, I get a negative quotient. And if A is negative and B is positive, I get a negative quotient. Next, let's think about some properties of negative numbers. So if I have a number A and I multiply it by -1, then I'll get the negative of that number A. For example, if I start with the number 3 and I multiply it by -1, then I get -3. If I start with a negative number, -A, and then I take the negative of that, then I get A back again. So for example, if I start with -3 and I take the negative of that, then I'll get +3. If I have a number A and I multiply it by a number -B, then that's going to be the same as if I have -A times B, and either way the answer will be equal to the negative of the product of A and B. But if I have -A and I multiply it by -B, then I end up with a positive result, which is going to be the product of A and B. For example, if I have A is 3 and B is 4, and I want to multiply 3 times the negative of B, so 3 times minus 4, that would be the same as if I have the negative of A, which is minus 3, times the positive of B, which is 4, and either way it's minus 12. But if I have the negative of A, so minus 3, and the negative of B, and multiply those two numbers together, then I'll end up with a positive answer. I'll end up with plus 12. Next, let's think about some properties of 0. So if I have a number A and I multiply it by 0, then I'll just get 0. Next, if I have two numbers multiplied together and the product is 0, then either A is 0 or B is 0, or they're both 0. And this is called the zero factor theorem, and it kind of looks fairly innocuous, but it comes up a lot when solving equations. Another property that comes up a lot when solving equations is if I want to subtract B from A, so A minus B, one way to do that calculation is to add the negative of B. So we've turned a subtraction problem into an addition problem. And again, this kind of looks a little bit innocuous too, but it does come up when we're trying to solve equations. Just as a quick example, if I had 3 minus 4, so one way to solve that is to take 3 and add minus 4. And then we can think about it in terms of the number line. We're starting at 3 and then we're adding minus 4, so we're ending up on the other side of the number line again. We're ending up at minus 1. Or another quick example, if I want to subtract minus 4 from 3, then one way to do that is to add the negative of minus 4. And the negative of minus 4 is plus 4, so that's going to be the same as adding 3 and 4, and we'll end up with 7. Next, let's think about inequalities, and we'll start with strict inequalities. So A is greater than B if A minus B is positive. So again, kind of linking back to the idea of the number line. And A is less than B if A minus B is negative. So for example, if I'm trying to compare 3 and 4, so I want to figure out whether we have a greater than sign here or a less than sign. And again, it kind of might be fairly obvious that we want a bit of less than sign here, but let's apply the definition here. So A minus B will be 3 minus 4. So that's minus 1, so it's negative, so 3 must be less than 4. What about 3 and minus 4? Do we have a less than sign here or a greater than sign here? So again, we'll apply the definition. So we'll do 3 minus 4. That's this example here. We got a positive result. So A minus B is positive, so A must be greater than B. We must have a greater than sign here. So it's quite easy when you're using inequalities to get things backwards. But if you think about it in these terms, think of these as definitions for these inequalities, then it's harder for you to go astray and get things backwards. So these are strict inequalities. There's also non-strict inequalities. So if we had a greater than or equal to b, so that means either a is greater than b or a is equal to b. And then similarly, a less than or equal to b, either a is less than b or a equals b. Finally, for this video, absolute values. So the absolute value of a number a is defined as a if a is greater than or equal to 0, or minus a if a is less than 0. So, for example, absolute value of 3 is 3. Absolute value of minus 4 is 4. So absolute values are always positive. So we could think of them as the magnitude of a number with no regard to the sign. So whether we're on the positive side of the number line or the negative side of the number line, the absolute value just tells you how far away from the origin you are. And that leads us to thinking about distances. So the distance between 2 points A and B is the absolute value of the difference between A and B. And it doesn't matter which way round you do the subtraction. It's the same as the absolute value of B minus A. So, for example, we could have the distance between the numbers 3 and 4. And as a second example, we could have the distance between the numbers 3 and minus 4. So just take a moment, pause the video, and apply the definition of distances in terms of absolute values to calculate what these two distances are. So for the distance between 3 and 4, if we were applying the definition there, so it's the absolute value of 3 minus 4, so the absolute value of minus 1, so 1. And then the distance between 3 and minus 4, so applying the definition again, 3 minus 4, so I have 3, and we did this example up here, 3 minus minus 4 was 7. So the absolute value of 7, and that's 7. And we can think about that in terms of the number line. The distance between 3 and 4 on the number line is going to be 1, and the distance between 3 and minus 4, which will be over here, is 7. So that's all for this video. In the next video, I'm going to switch gears a little bit and start thinking about fractions, and in particular, reducing fractions to their lowest terms.